We have described vector calculus, right? Previous online class with describing the gradients of the vector, divergence, right? I think these two we have almost describing. Then I think today we will describe curl and the Stokes. So let's see what exactly we have. So as I mentioned to you, there are about three coordinations, okay, or coordinates, which is first one is Cartesian, which is based on x, y, and z, right? And while we can say the differential distance, which is first derivative based on x, okay, then differentiate based on y, differentiate based on z, okay, as I already mentioned to you. So we can see by the gradients of a variable of t, which we can call it delta, okay, or gradient, okay, t, which as I mentioned to you firstly, we uh, apply this equation, derivative by x, y, and z, similarity with cylindrical coordinates as well as for the spherical coordinates. Please guys, this is very important. Number 1, 2, 3. What you need to do, you just need to distribute these things. Then also we have solved an example, okay, such as I think this example we already solved. Okay, then for example, if we have a gradients of a variable of v, right, what will happen? We have to differentiate these equations based on, okay, x, y, and z. Why? Because which we can see here, variable we have x, variable we have y, variable we have z. So this is Cartesian coordinates. So we have to copy this part. So once we copy this part, okay, we have copy here, okay, then you do the substitute only, okay. What exactly what you have to do? Number 1 here, you have to differentiate based on x. Where is x? X is here. Differentiate of sine to sine will be cosine to x multiplying by 2. So will be cosine to x multiplying by 2, while the rest will be constant. Then you have based on y, you have to differentiate based on y. Cos y is, you have only this part, cos y, which is the differentiate of this cos will be what? Will be sine. The rest is easy. This one and this one is constant, just rewrite it. Then we have to do it based on z. Z which is we have only here, so sine 2x cos y, you just rewrite it back as a constant, okay. Then you have e into the power of negative z equal the differentiate equal to e into the power of negative z multiplying by negative 1, so it become negative e exponential e negative z sine cos, okay, ez, okay. That's for the Cartesian coordinates. Then if you have a questions like this, okay, you have r, you have z, and you have phi. So what type of coordinates? Let's check. We have r, z, phi. Of course, one of this one, r, z, phi. Of course. So what is it? So we use cylindrical. R, z, phi, cylindrical. If you have r, theta, phi, you use spherical. Okay, since we use the cylindrical coordinates, you have r square, so you copy paste this part. Okay, then you check one by one. You have this part. So what is this part? You have to differentiate based on r. R square is 2r So z cosine 2 phi will be as a constant. You just rewrite it only. Second part, you have 1 divided by r. You just write it 1 divided by r multiplying by r square to become constant. Z also constant. Cosine 2 phi is equal to negative sine 2 phi multiplying by 2. So 1 r with 1 r, so you will have negative 2 rz sine 2 phi a phi. The last one, which you have differentiate based on z. Z you have only here. Differentiate of z is 1. You just write r square multiplying by cosine 2 phi. That's it. Once you see the last one, which equal to w is equal to 10 r sine phi theta phi. Okay, you have the variable r, phi, and theta. So let's say what is it? Of course, it's cylindrical. You have r, phi, theta, and phi, isn't it? So just write this one, since you need to find the gradients of this equation. Exactly the same we will do. Okay, since this is a spherical coordinates, we just write this part. Okay, then we use differentiate based on r. Okay, then where is r? R is here. R, we have 1. The rest is a constant, sine cosine multiplying by 10. You just rewrite it. E, you just rewrite er. Then you have 1 divided by r. You have to write 1 divided by r. Then you have to differentiate based on phi, differentiate based on y. This is, you have only this part, sine. So you have cosine, write it phi, okay, as a constant. So sine square, you have 10 also. Sine you will have is equal to sine square is equal to what? To sine phi. So you need also, you have r also, sine 2 phi. So r with r, you have 10 sine 2 phi cosine phi a. Okay, you need to know how to do these integrations. Okay, I believe you have more experience in mathematics to do this. The last part, which you have to differentiate based on phi. Based on phi, you have only here cosine. Cosine differentiate will be sine or negative sine phi. Then the rest you have to write it as a constant. Okay, directional derivative. Also, we have described directional derivative, okay, which is equal to equal to the gradients multiplying by unit vectors. Okay, you have to find the gradients vectors multiplying by unit vectors. So both multiplying to each other will be equal to directional derivative. Okay, let's see these equations. I will solve it. I will just repeat it faster. Okay, so we have this equations. T is equal to x square y square z. From here we have x, y, z. So this is Cartesian, right? Very simple, Cartesians. So since this is a Cartesian, let's find the gradients of this Cartesian coordinations variable. So what we will have? So we will have delta t. Okay, you can see delta t is equal to, you can just write this part. Okay, then you do one by one. So differentiate based on x square plus y square. Okay, so if I want to differentiate this part, let me write it here. So this is will be differentiate this based on x, then you have 2x. Okay, 2x, you have something here, you have 0, that's it. So you have 2x, you write it here. Then the second part, we differentiate based on y. Okay, y, here you have 0. Okay, plus y square z. So y square is what? 2 y, and z is a constant, so you just write z. then you write this part here. Okay, then differentiate based on z. Let's say what we can do. Z here we have 0, okay. Then we have z will be 1, so y square. Isn't it? Because y square? Because constant y square. Now, in this case, based on z, isn't it? Then you write y square. So the gradient is equal to 2x variable x vector plus 2yz y vector plus y square z vector. So this is the gradient. So once we find the gradients, we have to find the unit, right? So this is done, found. So we need to find the unit vectors, right? We already know many examples how to find unit vectors, okay? Which is giving to us here x 2x plus 3y negative 2z. Okay, so what we have here, okay, so you have L x squared plus 3 divided by the magnitude of L. We have root 2 squared plus 3 squared plus 2 squared, so you will get, this is the unit vector. Then once you find the unit vector, you multiplying both. So let's just multiplying both. What will happen? Okay, you have 2x multiplying by 2. Okay, 2x multiplying by 2x. So this will be what? X 2x multiplying by 2x vector. Okay, so is equal to 4 x vector x vector 2 is equal to 1, so is equal to 4x. So you write for x here plus 2y and 3. Since you already know that y multiplying by y is equal to 1, so you just multiplying these two only. So what you will have? You have about 6yz, isn't it? 6yz. You just also write it here. The third part, which we have it, okay guys, trying my best to show you in easy way. So we have y square, okay, and you have negative 2, okay. So what we will have? So we will have negative 2y square, okay. So this part, which you will have negative 2y square divided by root of 16. So we have already find the directionals of this vector, okay, but in the questions is asking us to evaluate it, which we have x is 1, y is negative 1, and z is 2. So we have to evaluate it. So once I reach here, I will evaluate it. Let's just remove, evaluate it. So 4 multiplying by 1, y1 here, this is x, this is y, this is z, okay, plus 6 multiplying by negative 1 and 2, and negative y is negative 2, negative 1 square, negative 1 square, sorry, I forgot to write 2 here, okay. What will happen? So is equal to 4 2 multiplying by 6 multiplying by 2 is equal to 12, right? 12. Then you have here negative 2, so negative 2. So here is equal to what? Negative 10, isn't it? So negative 10 divided by root 17. Is it clear? This is very important example. I repeat it This example is very important. Please you have to practice the same example also, maybe later at your home. Okay, then we have the second one is the divergence of vector field, right? Which I already said that we have positive divergence, negative divergence, and we have zero divergence. Positive, which all the sign will go out from that atom or from that position. Then the negative divergence, which all the electrons comes into one point, or you can see all comes to that particular point, which is B example. So zero, which they have to cross in one side. Okay, so we can see that the divergence is delta dot A, okay, which we already know how to calculate both dot A, which is the point, and we already see that the divergence could be equal to all the integrations front, back, left, right, top, bottom. Okay, you can see an example for this, and there are also fixed equations for the divergence of vector field for the three coordinates, which are, we have Cartesians, cylindrical, and spherical. So these are fixed. Okay, these are fixed equations for spherical. Three Cartesian, cylindrical, and we have for spherical. You have to make sure that what exactly the question is asked. If the question is asking for Cartesian coordinates, so we have to follow the Cartesian equations. Okay, if it's asking for cylindrical variables, then you have to go for that particular variable. Okay, also the total facts here, we will solve it maybe in chapter 3, how we will solve electric field when we have all the surveys are excited all the electron here. So we can see this is later. Okay, let's see this example. Find the divergence of this vector. Please guys pay attention. So we have these vectors. B is equal to x square y z x z a z. So we can see from here, this is a Cartesian coordinates. Since it is a Cartesian coordinate, then we have to write this equation. Okay, we write this equation, which is the easiest equation I can see among all the coordinates. So we have to write it. So we have to differentiate based on x. Okay, you can see bx mean I have to take only this side. So I take this side. Okay, I replace it, I put it here. That's it. I don't do anything, creativity. Okay, so the second one, which the differentiate based on y. For y, where is y? We don't have y here. Actually, it is like this: positive 0 a y. Okay, we don't have a y, so 0. So this will be 0. We have z here. You can see this z here. So this is only for z. So you write x z. So you write x z here, isn't it? So once you write this, now it's simple. Just you need to do the derivative or the differentiate. Differentiate based on x here. You have 2x, 2x y z. Very simple. Differentiate of 0, of course, 0. Differentiate based on z, of course, this is 1, so it's equal to 2x. So I believe all of you know how to do all this, right? Since you have taken calculus before. So let's move into the second question, which is asking also the same divergence of these vectors. So we can see we have r, we have phi, we have z. These variables are for cylindrical coordinates. Okay, cylindrical coordinates is this one. So we have to rewrite this equation exactly. So once we rewrite this one, so okay, this is just rewrite. Then we check 1 divided by r, 1 divided by r. Okay, differentiate. Then you have qr. QR or AR is the same. Okay, sometimes they put it variable A, sometimes the variable is Q. Doesn't matter as long as they are at the same variable. What we have here, so we have R sine phi. Okay, so they have R sine phi. Okay, I think this is R, not R squared. Then you have 1 divided by R, differentiate based on phi. Phi is this side, so you write this side. Then here you have EX. This is also EX or phi, it doesn't matter, so you write this part. Then you want to differentiate, so 1 divided by R, so R sine R is equal to what? Or this is 2. I don't know. One of them is not correct. Either here is written 2 or here is R. So anyway, you just differentiate with this is equal to sine, okay, to R. Then differentiate R square Z based on phi, okay, which is 0. Okay, why 0? Because we don't have phi here. No, there is no phi here. So this is constant. Differentiate of any constant becomes 0. Very simple. Then here differentiate of Z. Z is 1. So you have only cosine. So you will write only cosine. Very simple, right? As long as you know how to do the differentiate part. Then the third part which you have to use, or is it? Yes, you have R, you have theta, and you have phi. This is, we already know this variable is for the spherical. Where is the spherical? Okay, this is the spherical. So we rewrite the spherical part. Then we go back into the spherical part. Just write back. You just rewrite this one. Very simple. You can just follow 1 divided by R. You have differentiate R square omega R. So you have to write. Okay, then differentiate based on R square. You have to write I square omega R. Then you have to write the second one here. And the third one is here. Okay, 1 by 1. So the first one we have it is a cosine phi. One divided by R here, actually 1 divided by R. Okay, then you have here R cosine sine, and you have phi, this one. Okay, then I think all of you know how to do the differentiation part. Okay, you know how to do how to differentiate the equation. Okay, that's all for this divergence. Only based on, if you know how to do differentiate, I think the rest is very simple. Just only use the coordinates equations. Okay, so we can also see the divergence integrations. dv also is equal to E dot dE. Okay, later we will use this as electric field. Okay, in chapter 3. So also we can see calculate the divergence of one of these equations. Let's see. Equation number 1, we have 3x squared plus 2x plus x squared z, while we have points are for x are 2, for y are -2, for z are 1. Very simple. So we just need to find the divergence. So the divergence for number 1, 3 x squared, 3x squared, just write it here. Okay, then for y, 2y, just write 2y here. Then for z you have x squared z, so x squared z. Okay, once you do this, very simple, just need to do what? Differentiate of 3x is equal to 2x multiplying by 3, so 3 multiplying by x equal to 6x equal to differentiate based on 2x. We don't have variable of y here, then 0, because it is a constant. differentiate with any constant is equal to 0. Then here based on y is equal to what? Z equal to x squared. So you have x squared. So this is will be equal to x squared positive 6. While we have variable here are 2, negative 1 and 0. So this is also equal to 2 square plus 6 multiplying by 2, which equal to 4 plus 12, which equal to 16. Okay, so we can see the divergence of this vector is equal to 16. Okay, so let's see the second one, which we have r and theta. Okay, and of course phi, but it is not, I think, since you have these two variables are represent the spherical coordinates. You write the spherical coordinate, okay, here. Then you have to continue. You have a differentiate based on r square er. Okay, you have about r power 3 cosine this part. You write it here, okay, instead. So you have r square with r square. So you will get only e power 3 cosine theta. Second one, 1 divided by r sine theta. You have this differentiate EO sine O, okay, which you have the second part, and you can see the second part here. You don't have theta you have here. You have e into the power of 3 sine phi divided by r square, okay, by negative. Then write it back here, okay. The last one, which for phi here plus, you should be plus 0 phi. Okay, since this is 0, so this becomes 0. Then normal differentiate, you do it. So you have differentiate based on r here. You don't have variable of r here, so this is also becomes 0. Then you have only this differentiate to find it, okay, which equal to negative 2 e power 3 cosine, because you have sine square, okay. The differentiate are cosine phi divided by r into the power of 3, because you have here r and r into the power of 3. Also sine square is equal to 2 sine cosine, and one of them sine with sine, you will get only cosine. So the output will be the divergence of this vector is equal to negative 2 a into the power of 3 cosine phi divided by power 3. You have also here a into the power of the e divided by 2, this is r. Okay, then this is also theta is equal to 0. So since you have theta is 0, so this is equal to 2 e power 3, and you have cosine 0 is 1, okay, divide by r into the power 3, r into the power of which is e power 3 divide by 4, a with e3, right, and you have 2 and 4, not 4, this is 8, okay, 8, because 2 into the power of 3 is 8. 2 multiplying by 8, you have negative 16. So we can see that the final value of the divergence of the spherical coordinates is equal to negative 16. Is it clear? Do you have a question, guys, based on this? Okay, if you don't have a questions, this is also very simple one, as long as you know how to do the differentiate part. Please, guys, if you feel if you find any difficulties in based on integrations part or differentiating part, okay, feel free to contact me through team. Okay, just let me know that you have a problem in this model, okay, or this equations, you don't know how to do this. It doesn't matter, even though I am happy to help you and describe it to you. Okay, please don't feel shy, ask me. Okay, especially for any part. The curl, okay, for the vector field, we can see the circulations here is based on the integration part, as I mentioned. For example, you have this circuit or setup, while we can see the unit form are crossing into one side, right? And we can see the also the vectors are also exciting or moving through that side. Also the curl also of the variable of p here we can see, which is based on the rotations, okay, into one point here, okay, through any points. For example, you have here is Cartesian coordinations, which we can see also the effect of magnitude through the maximum circulations. Okay, that's the theoretical part. Also, we can repeat it later. So the integrations part based on curl is equal to integrations from E to B. Okay, so you have here A and B. So you have value here, distance. Okay, then you have from B to C, you have distance here. Then you have from C to D, and you have from D to A. Okay, that's the normal integrations, okay, around all this circuit, okay, or configurations part. Also, we can see also the curl of vectors is also equal to delta cross B, okay, and I know all of you how to do cross, right, which we have to use a metric, okay. Don't worry about limitation part here, is okay, just to show you the limitations or more deeply equations. So we can see what is the purpose of the curl of vectors field, which is to measure the uniformity of a field. To measure the uniformity of any kind of field, electrical field, magnetic field, doesn't matter what is it, because normally we will only use this one for these two purposes. A uniform film, as I said, we need to use it for to find it piece, which we have to use the curl equations. Okay, that's only when we have uniform film, and if we have the rotations field also, we can use. It looks like this, which is never equal to 0. Okay, and this part, if we uniform field which have a constant value like this distance, it is also can equal to 0. But here if it is in the rotations into one point, it is never be equal to 0. So this circulations is never equal to 0. So let's say some of these properties which we have. For example, we have delta cross A plus B, which can be equal to delta cross A plus delta cross B, right? And if we have delta dot delta cross A, this is could be equal to 0. And if we have delta cross delta V, which is gradients of V, is equal to 0 also. And of course, as I already said before, so once we have delta cross A, right, for the Cartesians, so we have to use the matrix. And I believe all of you know how to use the matrix, right? Ex, so you have this part multiplying by this part, negative this part multiplying by the other part. So defined one part. Exactly the same for AB, AY, then exactly the same for AZ. Okay, I believe all of you know how to do the matrix point. Okay, there are two ways. Either you want to find it by using the matrix, or if you want to use this formula directly, also you can use this formula directly, because this subject is not mathematics 100%. Okay, so you have to use this one also as well, is also correct. If this formula is providing to you, so directly go and substitute that particular formula. Then of course for the cylindrical coordinates, okay, we have to use this formula delta cross A, which you have 1 divided by AR, then the rest become the same. But be careful guys, you have to know the variable of the cylindrical, which is R phi z. Be careful. The Before you solve any questions, you have to identify what is the coordinates type. Is it Cartesian, cylindrical, spherical? We have only three types, not more than three times. We have only these three times. Then you will get this one. If you want to use the metric formula also to find this part, you can do. If you go through this formula directly also, it is correct. Then we have the third part, which is spherical coordinates. Okay, spherical coordinates also same, but you have to be careful. You have r, you have phi, okay, and theta, okay, and theta and phi. So you have all this. You have to know this one, okay. Then you have the formula. You have this formula, okay. Then from this formula you can find the curl in spherical coordinate if you have delta cross A. I have already, I think, identified these points, if you remember in the previous slides, okay, and we have solved some example in Cartesian coordinates only. But here the curl could be for three types of coordinates, could be for Cartesians, and can be for spherical, it can be for cylindrical. Let's see this example, okay. We need to find the curl of these vectors. The curl of these vectors are this part, okay. You can see here x, y, z. Okay. Once I see x, y, z, and you have ex, ez, of course there is also y, but it is 0 here, plus 0, e, y. In this case, once you see it, you will find this is our Cartesian coordinates. If you have Cartesian coordinate, then definitely you will apply the Cartesian coordinate point equations, okay. You just write this one, okay. You can write this part, okay. Then let's do it one by one. Differentiate based on z, bz, okay. So bz here, so you have here z, okay. So ex and based on y, so this is 0, so you have 0 here. Then differentiate based on z for y, based on z for y, you don't have, you have 0 here, then 0. So all these sections is 0. Then you have negative, differentiate based on z, x for z, what you will have. So you have for z, okay, you have this part. What you will find here, so you will have x square y, okay, negative, because you have z here, 1 become negative z, okay, positive. Okay, so since you have negative also, the integration of bx divided by z, so also here you will have equal to x square y, okay, z, oh sorry, you have xy negative z. So this is equal to negative x square y, okay. Then you have here negative or positive z. Since you have negative here, so negative multiplying by negative become positive, negative multiplying by positive become negative, so equal x square y negative y. Then for the last one, b for x also 0, because we didn't have variable of y into x. Then you have bx divided by integrations for also z, y, which equal to what? Y, x square and z here, okay? X square z. So at the end you will come out with the curl equations. If it is giving to you evaluate this at this point, you have one, for example 2 and 1 here, and ask you to find, so you will just put the points here, which equal to 1 square multiplying by 2 is 2, 2 negative 1 is 1, ey, negative 1 square multiplying by 1 ez, so this is equal to ey negative ez, okay? In case this is giving to you, in case, okay? I'm just telling, in case it has been the point has been issued in the questions, you can put it here. The second one, which we have using the cylindrical coordinates, you do the same as well, okay? You have to integrate one by one or differentiate one by one, okay? These are 0, okay? Then you have to differentiate based on this and this one. At the end you will come out with the final equations. Also the same for the spherical, okay? The spherical long equations, okay? But doesn't matter as long as you follow the steps one by one. I think it won't be that problems, okay? So you just follow, differentiate each part until you reach the final answer, okay, which is this one. Okay, so I advise you guys to practice at home, okay? Then Stokes theorem, which is used to convert the surface integral, okay, of the vectors over an open surface. So we have this open surface which will be converting into a line integrations vectors and through any surface of S and so on. So it will be identifying the vector along of C surface here, for example, which could be equal to what? Delta cross B, and we have integration. So at the beginning you have to find this delta cross B, then you put the integration part. That's, we call it Stokes theorem. Very simple if you use this one. Let's say this example. So a vector field is giving here, we have B is equal to equations here, right? And we need to use what? The Stokes theorem. So verify mean proof. While we have the surface R is equal to 2, and we have the angle in between pi divided by 3 then in less than pi divided by 2, so and z are greater than 0 and less than 3. We already identify this is cylindrical surface. Okay, cylindrical surface, you can see R is from here to here are 2, z here is 3, and we have 2, so R in between 2 and 3, okay? And we have, these are the two angle, pi divided by 2, and we have pi divided by 3. So let's use the Stokes theorem states. Stokes theorem states said the left hand side is equal to delta cross B, and we have to put the integrations part. So first of all we have to use delta cross B. How to find delta cross B? So we have to use the curl equations, right? The curl function. The curl functions, you write it, okay? Then distribute to find delta cross B. So I think you can do it by your own later. You have to differentiate based on phi, then you have based on z, okay? Then here between z, r, and you have z and phi, one by one. At the end it will come out to you this one, negative r sine divided by r squared, positive phi cosine phi divided by r squared. So once you find this, then you put into the integrations part. Once you put into the integration part, of course, if you can see here, so we have two variables, okay? R, z, and phi, right? So I have 3. So we have first one here, second one, okay, and third one, which is comes from here. So we have r2, so it could be from 0 to 2, but we don't have variable of r here, so I think we don't use r. So we have to use only for z 0 to 3, and we have for the angle pi divided by 3. Okay, so we have here from 0 to 3 for z, and the second one, which we have pi divided by 3 for phi, to pi divided by 2. Then where is the equations? These equations will be available here. Okay, then you have dot r t phi del z, isn't it? This one, the surface equations, which we already highlighted in some other points. The difference between is we have to use the curl equations, and we combine the curl equations into the the volume equations, right, which we have already done before, if you remember in previous slides. So it is all comes together. So if you study, you have to study it in one flow, one by one. So if you do these two integrations part, okay, at the end, integration 0 to 3, okay, r cosines, then you will get sine phi divided by r. Okay, since you have r squared cosine r squared here, phi, okay, so you will get is equal to 3 divided by 2r. R here are 2 from the questions. Okay, here. So 2 multiplied by 3, so we will have 3 divided by 4. So that's from the left side. So if I move into the right side, which is this section, okay, this sections which I said you have to multiplying from A to B, B to C, C to D, D to A. So we would like to do all these points. So let's see, from B to A and B to C are equal to each other, which could be equal to z cosine phi divided by 2, okay, which can be equal to 0. The second part, which is B to C, which equal to z cosine pi divided by 2, which we have phi equal to pi divided by 2. Then you have B dA, okay, then you have pi divided by 4. Okay, so if you say all these parts, so you will have A divided by D only, A divided by D this part, from Z divided by 4, Z D Z. So you have from 0 to 3, which you can see is equal to 3 divided by 4. So what we can conclude here is the left hand side is equal to the right hand side. That's for the so we have proved that the left hand side of the equations of the Stokes theorems is also equal to the right hand side. If it is not asking you to verify and only asking you to find using these sections, you don't need to, you need to find one of these points is enough. Either you want to use the left side or you want to use the right side. Laplacian operate, I think this is the last sections here, okay, but don't worry, I mean these sections, it is not going to be included in your exam, just for you to understand, especially this section. These sections won't be included in your exam, okay, but you have to understand it, okay. So these sections is also easy, but the problems, it make it longer, because you have to differentiate 2 times. You have to have 2 gradients, okay, you have to have 2 gradients, square gradients. So delta dot delta v, okay, so you have to find the second time, the second ordinary differential equations, or the second differential equations. Second differential equation I know already of you, right? For example, you have, if for example you have x square, what is the differentiate of x square is what? The first differentiate are 2x, the second differentiate are 2, isn't it? So this is the second differentiate, which is this part. So be careful, guys. As I mentioned to you, you need to understand it. I don't think it is going to be included in any of your exam. Okay, and also it has a 3 coordinates. The first one, which is deal with a by a x y z, okay, which is simple, also exactly similar to the previous the gradients, but here you have second differentiate, so you have to differentiate first one, differentiate the second one. Okay, be careful. Let's say if we have here some value, you can just differentiate 3 times. For example, you have x squared, so x squared will be only here, so will be 2x, then second one will be 2, so the answer will be here is 2. Exactly same for y, exactly same for z. This is for cylindrical and this is for spherical point as well. Let's say you have the first one, so I think this is we will solve before we end the session. E into the power of negative z sine to x cosine y. We have solved this before, if you remember, right? We have found the first integrations only, but if you want to find the second, so we have to differentiate 2 times. So we have to differentiate 2 times for this. For example, this one is x, so you have cosine 2x multiplying by 2, then you have e into the power of negative z cosh. So this is for number 1. Okay, this is first differentiate. Second differentiate, which you will have e into the power of negative z. Okay, you have 2. Okay, then you have cosh y, then you have cosine to sine will be negative sine 2x multiplying by 2, also 2 with 2 will be 4, 4e into the power of negative 2. Okay, then you have cosh, you have negative, then negative sine 2x. Okay, that's only for one point, for this point. Then you do it for y, then you do it for x until you reach 2 points. So this is for number 1 part. Then you do it for y, you do it for y. We have cosh, cosh will be what, sine y, and the rest you write it same. Then you have cosh y also negative, then you write. Also you do it for z. Z is very simple. First differentiate of z will be e into the power of negative z multiplying by negative. The second differentiate also will be e into the power of negative z multiplying by negative, negative become positive. So I think the second differentiate actually for this will be exactly the same. Okay, so this is for number 1. If you want to solve it for Cartesian coordinates. The second one also, if you solve it for the cylindrical coordinates, is equal to 0 also. But if you solve also for the spherical coordinate, also is equal to a value here. Okay, so also this is some of the properties. Delta square A is equal to delta dot A. It's also negative delta cross A. Also, you can assumptions. So at the end, you can see the relationship of all. You can see the distance between 2 points. You can use this is for Cartesians. Okay, you can use this is for the second coordinate, which is cylindrical. This is for spherical. Okay, so these also the transmissions points you have already in table 3.2. The coordination system you have in table 3.1. Okay, vector product, this is also highlighted to you. Divergence, you have it. Vector operations you have, okay, and Stokes theorems you have here. Okay, that's all the equations which you needed in this chapter. Okay, so quiz will be next week, I think by 17 February. Okay, the last point, which is Laplacian of vectors won't be included. Okay, so this one won't be included. Everything is included. Wait, guys, except this one. This point is here not included. Okay, here not include. Okay, the rest everything is included in your quiz. Okay, don't worry about the quiz as long as you know how to use the formula. Okay, I believe that all of you can achieve a good mark. Okay, don't worry if the questions you don't understand it, you can just ask me. Okay, what you only need to know, don't look into the questions, look into the formula, understand the questions identify what equations you need to use, what coordinates is this equations, then use that particular formula. Okay, is it clear? So do you have a question, guys, before we ending the sessions? I think the time is almost finished. Please feel free to ask me at any time. You can also ask me now, no problem. Hello guys, are you around with me?
Yes, sir. Thank you so much. And take care.
Thank you.
Thank
Is
you
there
so much,
any
sir.
others? Yeah, is everything okay, guys, with you? Please
Yes,
try
sir.
to practice at home.
Yeah, it's just a matter of practice. Otherwise, everything is so clear.
Yes, everything is there, and you are allowed to use the formula also during the exam. Okay, as long as you know how to use it, as I am, it is good enough.
Right, sir.
Okay, so if you don't have any questions, then at that sessions, I will end today's sessions. Then I will see you next online class.
Okay, sir. Take care.
Okay, thank you,
Okay,
guys.
sir. See you.
Okay, bye.
Thank you, sir.